Hi everyone, welcome back to my channel. I am Dr. Shabazz here. So in this video, we will learn how to assess common method bias in R. Common method bias may occur when information for dependent and independent variable is collected from the same respondents through the same survey questionnaire and at the same time. In such cases, part of the observed relationship may result from the data collection method rather than the actual relationship among the variables. One widely used diagnostic is Harman's single factor test to check the common method bias in our dataset. All measurement items are entered into an unrotated exploratory factor analysis. If one factor emerges or the first factor explains most of the total variance, commonly more than 50%, common method bias may be a concern in our data. However, Harman's Singh test alone can't prove that common method bias is absent. It should be supported by stronger methods such as a common latent method factor, marker variable technique, or full collinearity assessment, as well as appropriate procedural controls during questionnaire design and data collection. In this video, I will demonstrate how to conduct Harman single factor test in R, examine the first factor explained variance, and interpret the findings carefully. Please like the video, subscribe to my channel, and turn on notifications for upcoming videos on R data analysis. So first of all, we will consult our PowerPoint presentation to see the threshold values, to check the techniques and assumptions. Okay, so we are going to test the common method bias of our dataset. So we are checking whether the measurement method may account for too much of the observed relationship among variables. So we will test Harman single factor test, marker variable CFA, and full collinearity checks. So common method bias can arise from the way data are collected. Examples of a common method: same questionnaire and response scale, same respondent provides all variables, same time and context of measurement, social desirability or acquiescence, similar wording across items. So why it matters? Common method variance can inflate or deflate correlations, producing misleading reliability, validity, regression, and SEM results. Use multiple diagnostic rather than one decision rule. So we will test using 4 methods: Harman one factor test, marker variable approach, confirmatory factor analysis, and full collinearity various inflation factors. So we have a data of 20 respondents and we have 3 variables. First variable is green employee involvement with 2 survey items. Second variable is ethical leadership with 2 survey items, and green creativity with 2 survey items. And we measured the items on 5 points Likert scales. So Harman single factor test is an exploratory screen. So we will test and use Harman factor by an unrotated exploratory factor analysis using all substantive items and examine the variance explained by the first factor. So common rule of thumb: if the first unrotated factor explains less than 50% of total variance, severe common method bias is not found in data. So now we will test the common method bias in R. So we will go to R and we will import the data here. So I give data to ChatGPT for coding. So we'll see the first coding to import the dataset in R. So we copy this prompt and then paste here. Press enter. So you will see the dialog box. So we will copy the command and paste it our console and press enter. So you will see a dialog box open and you can select your data and then click open. So data has successfully opened in our RStudio. So you can see the observation number of variables. Okay. So next we select the questionnaire items for common method bias. We copy and paste the command here, then press enter. So items has been selected for common method bias test. Okay, now we need to install two packages to test the common method bias in our data. First is Psyche and second is Write Excel. So both packages we have already done. So if you don't have, then you can install in your RStudio. So we just need to load the packages in R. You copy and paste and then press enter. So both packages have been loaded in RStudio. So now we can perform common method bias test. So first we perform Harman single factor test. Copy this prompt and then paste in console and press enter. So you can see here by using the principal component method PCA, there is a standardized loading pattern matrix based on correlation matrix. So you can see here the loading of factor loading of green implied involvement is 0.95 and item 2 0.86. So it means the factor loadings of all variables are higher than 0.7 according to Higher and Ringel et al. Criteria. So it means we accept the factor loading of all variables by using the principal component analysis PCA. On the other hand, we also see the loading proportion variable, cumulative variable, proportion explained and cumulative proportion. So mean item complexity equal to 1.6. Type of the hypothesis that 6 components are sufficient. And the root mean square of the residual is 0 because the value of RMSR should be less than 0.08 with the empirical chi-square 0 with probability less than not log. So in this way, because we have concerned with the factor loadings and all factor loadings are higher than 0.7. Okay, so now we see the eigenvalues and explained variance. We copy the command and press here. You can see here the eigenvalue is 4.61 as well second item 0.72 and third item 0.34, 4.3 and fourth item and 6 and 7 as well. Okay, so next we also see the we counted, paste and then enter. So you can see the SS loadings as per our eigenvalues according to principal component analysis and proportion variable, cumulative variable, proportion explained and cumulative proportion. Okay, next we apply the percentage to check the single factor variance. Paste and then press enter. So it means all 6 variables, 6 scale items explained 76.8284% of total variance. So it means the value of first factor percentage is higher than 50%, so it means there is a strong biasness in our data set. So next we apply the extract first factor loadings. So you can also see here each factor item loading as we have just done in the first prompt. You can see here this one. So because the loading of all variables are higher than 0.7, so there is a good validity of the survey items. However, there is a strong biasness in our dataset because the all variables explained 76.8284% of total variance, which is higher than 50%. So in this way, we check the common method bias in our data in R.